In the early 1880s, electricity, running in direct current, would decrease in voltage over distance, limiting the reach of a single power generator to about a mile in any direction. The Serbian inventor, Nikola Tesla, explored an alternative to direct current, alternating current, which he discovered was without the aforementioned problems. He encountered much opposition from both direct current competitors and in a difficulty funding the necessary apparatus. Despite the opposition, the advantages of Tesla's system were eventually recognized, and it became the standard for power transmission over power lines. As a result, electricity became safer and more efficient, creating a brighter future for America.
Thomas Alva Edison, the famous inventor of the practical light bulb, the phonograph, and much more, was the foremost provider of electricity in America in the early 1880s. He had, hoping to replace the gas lighting system, developed a direct current or DC system, that is a system in which electrons flow in one direction. He established the Edison Electric Light Company, which installed its first power plant on Pearl Street in Manhattan in 1882. The companies had soon installed an abundance of DC power plants throughout America, even expanding to other parts of the world. Soon, Edison's career was relying heavily on his DC system power plants. His system was, though better than previous gas lighting systems, in many regards inefficient and unreliable. Wires to transmit DC had to be massive to minimize resistance, but voltage loss was still prevalent.
When you have a DC system, you can't raise or lower the voltage. So you start out with a high voltage, you run it down the street, you heat up the wires, and then the voltage drops. Pretty soon you can't supply your load anymore. You got to build another generator down the street a ways.
Some engineers previously had used a system of alternating current, or AC, where electrons reverse directions many times a second. Noticeably, Eli Pixie, who, in 1832, built the first AC generator or alternator, based on Michael Faraday's principle of electromagnetism. At this point, however, AC could only be generated and was without any practical application, so no one considered it a viable system.
However, Nikola Tesla thought otherwise. He had, in his schooling throughout Eastern Europe, explored that AC was not only viable and useful, but also had major advantages over DC. He first explored the idea of an AC system when at Polytechnic School in Graz, Austria. He noticed the unreliability and inefficiencies of a DC generator, or Graham dynamo. He suggested that the source of these problems were the commutator and brush, and that the problems could be easily solved by converting the machine to AC, eliminating the commutator and brush. Upon revealing his idea, his professor Polsho responded, "Mr. Tesla may accomplish great things, but he certainly will never do this." But Tesla was not deterred. He often spoke of how alternating current would change the world of electricity. Then, in 1882, as he was walking and reciting poetry, like a flash of lightning, the workings of his idea dawned on him. He immediately proceeded to draw the design for his AC induction motor, the first practical use of AC, in the sand. Tesla developed a viable AC system with alternators, more induction motors, and transformers, which could easily raise the voltage for more efficient transmission over distance, and just as easily lower the voltage to the correct voltage for a task. This proved to be the primary advantage of AC over DC.
AC raise the voltage, I can send it hundreds and hundreds of miles.
And those transmission lines need to be at high voltages in order to keep the current low. So for very practical reasons, you need transformers.
It's a lot simpler to build systems that way.
Tesla decided to seek out a job in America. He arrived in New York on June 6, 1884. He came with very little possessions, only 4 cents, some poems, and a letter of recommendation from Charles Batchelor, his previous employer. He then encountered Thomas Edison, showed him the letter of recommendation, and was hired by him. He was distressed to hear that Edison worked strictly with DC and that he would not consider AC, but he continued to work under Edison. Soon after, Tesla was promised $50,000 to make some improvements to Edison's dynamos. Tesla worked restlessly for months, but when he asked Edison for the money, he responded, "Tesla, you don't understand our American humor." Tesla quit tempestuously and resorted to working for $2 a day digging ditches. Things started looking up for Tesla in 1887 when he gained attention from investors through speeches and presentations about his AC motor. He sold some AC system patents for the fundings of his first laboratory. He sold his AC polyphase system patents to George Westinghouse, who would continue marketing Tesla's system for $75,000 of cash and notes. Despite the advantages of AC, Tesla encountered many who were opposed to the introduction of it. Many inventors tried to legally discredit the new system, each one claiming that they had conceived the idea first. Next, Edison, being a major contributor to DC systems and not wanting to lose business to AC, electrocuting animals with high voltages of AC, saying that these animals were Westinghoused, and warning the public that if they accepted the new system, a similar fate may await them. Edison, writing to E.H. Johnson, said, "Just as certain as death, Westinghouse will kill a customer within 6 months after he puts in a system of any size. It will never be free from danger." Next, Edison, with fellow AC opposers, hoping to further convince the public that AC was dangerous, created the electric chair, a means of execution by AC electrocution, the first victim of which was the sentenced murderer William Kemmler, who was Westinghoused on August 6, 1890, a horrible event that required 2 shocks to kill the man. Regardless of the opposition, Tesla and Westinghouse eventually had their victories. The 1893 Columbian Exposition, or Chicago World Fair, was approaching, and plans were made for a massive lighting system. Offers were made by several companies, but the 2 main candidates were Edison's company using DC electricity and Westinghouse's company using AC electricity. The AC system allowed Westinghouse to offer for a considerably lower price than Edison. So, Tesla's alternating current system was selected to light the fair. The fair was a fantastic success, a great spectacle of the power of AC. The ability for AC to complete such a task was a turning point in many people's minds about AC. The public finally accepted that AC had its advantages and that it was a useful and efficient system.
Their success immediately resulted in continued opportunities for Tesla and Westinghouse. In October of 1893, they were commissioned to build the first generators powered by Niagara Falls, a dream of Tesla since his youth. The generator supplied an amazing 15,000 volts of AC to the city of Buffalo, New York. The application of AC also led to many of inventions of both Tesla and those inspired by him. These include the Tesla coil, a transformer capable of creating artificial lightning, Tesla radio, which uses an alternating current to broadcast sound waves, and Tesla's telonautic boat, a first in robotics and remote control.
Obviously, we have a coast-to-coast widespread power network today. That is the fundamental biggest advantage of introducing AC power.
The ability to change the voltage of AC with a transformer and transport electricity with virtually no loss allows the widespread use of electricity throughout America. Using Tesla's AC system, big cities continued to be electrically supplied across America. The residents benefited from electrical lighting as well as electrical appliances. Then, during the Great Depression, President Franklin Roosevelt established the Rural Electrification Administration, which provided AC electricity to small towns and farmers. The many appliances and devices of electricity then became readily available throughout all of America. The exploration with alternating current by Nikola Tesla spurred the world of electricity and technology forward.